This video is about finding the value of sine, cosine, and tangent at special angles. This is AP Precalculus topic 3.3. If you appreciate this content, please give it a like. For the next few problems, assume that the blue line is the terminal side of an angle theta in standard position. If the terminal side passes through the point x, y on a circle that has radius r, we know that the sine of theta is defined as y over r. The cosine is x over r, and the tangent is y over x. Memorize these basic formulas. So on this circle, sine theta is y over r. In this case, that is -3 over 5. The radius is 5. Cosine theta is x over r, so that's -4 over 5. And the tangent of theta is y over x. That's -3 over -4, but a negative divided by a negative is a positive. So let's put +3 over 4. On this problem, sine is y over r, so in this case that is 4 over 5. Cosine is x over r, so that's -3 over 5. And tangent is y over x, so that's 4 over -3. On this problem, sine theta is y over r. In this case that is -5 over 13. Cosine is x over r, so that's 12 over 13. And tangent is y over x, so that's -5 over 12. The next few problems involve a unit circle. A unit circle is just a circle with a radius of 1. So sine theta is y over r, but on a unit circle, that's y over 1. Of course, we don't need to write the 1. So on a unit circle, sine theta is simply the y value. Similarly, cosine theta, which is normally x over r, becomes x over 1, or simply x. Tangent is no different. It's y over x as always. On this problem, notice that it is a unit circle. On the unit circle, sine theta is just the y value. So that's -1/2. On a unit circle, cosine theta is simply the x value. So that's -3 over 2. Tangent theta is y divided by x. So I'm going to show a step that I normally do in my head. We have the y value divided by the x value. Notice that the denominators are the same, 2 and 2. These will cancel each other out. Also, a negative divided by a negative is a positive. So we are left with 1 over radical 3, which is also equivalent to radical 3 over 3. Just to be extra thorough, let me show this in another way. When you divide a fraction by a fraction, you multiply by the reciprocal. So we will have 1/2 times the reciprocal 2 over radical 3. I dropped the negatives because a negative divided by a negative is a positive. And then the 2's cancel each other out. And we are left with 1 over radical 3, which is equal to radical 3 over 3. If you are not sure how I'm getting from here to here, I am multiplying by radical 3 over radical 3. 1 times radical 3 is radical 3, and radical 3 times radical 3 is radical 9, and the square root of 9 is 3. For this problem, we are still on the unit circle. Therefore, the sine of theta is just the y value, which is radical 3 over 2. Cosine is just the x value, so that's negative 1/2. Tangent is y over x. A positive divided by a negative is a negative. The denominators will cancel each other out because they are the same. So I'm going to end up with radical 3 divided by 1, which is just radical 3. So negative radical 3. Once again, we are on the unit circle for this problem. So sine theta will strictly be the y value, which is negative radical 2 over 2. By the way, this is equal to negative 1 over radical 2. Just get comfortable with the fact that these are the same. Cosine theta on the unit circle will just be the x value. So that's positive radical 2 over 2, which you might see written as positive 1 over radical 2. Tangent theta is y divided by x. A negative divided by a positive is a negative. And then we just have radical 2 over 2 divided by radical 2 over 2. A number divided by itself is 1. So tangent theta equals negative 1. At the end of the video, I will show you where some of these values are coming from in case anyone is interested. But for now, I want you to memorize the following values. You really have to memorize 3 values, and then the other 6 values flow from that. I need you to memorize that the sine of pi over 4 is 1 over radical 2, which is equivalent to radical 2 over 2. The second value I need you to memorize is the sine of pi over 6, which is 1/2. And finally, you must memorize the cosine of pi over 6, which is radical 3 over 2. I need you to memorize these 3 facts by brute force. Just flashcards, whatever you have to do, pause the screen, write it down, rehearse it, look away, write it on scratch paper, memorize these 3 facts. But the other facts sort of flow from these 3, because the cosine of pi over 4 is the same as sine. So you don't really have to memorize it separately, just remember that these 2 are the same. So 1 over radical 2, which is equal to radical 2 over 2. The reason why you don't have to memorize these values separately is because these values just sort of crisscross like this. So if you know that the sine of pi over 6 is 1/2, then the cosine of pi over 3 will be 1/2. If you know the cosine of pi over 6 is radical 3 over 2, guess what? The sine of pi over 3 is radical 3 over 2. These values just crisscross. You do not need to memorize the tangent values separately because tangent is just sine divided by cosine. I have it all lined up for you. So in this case, that is radical 2 over 2 divided by radical 2 over 2. A number divided by itself is 1. So the tangent of pi over 4 is 1. The tangent of pi over 6 is 1/2 divided by radical 3 over 2. Notice that the denominators are the same. So these are going to cancel each other out, and we will be left with 1 over radical 3. So the tangent of pi over 6 is 1 over radical 3. Rationalizing the denominator, this is equivalent to radical 3 over 3. Know that these are the same. And then the tangent of pi over 3 is radical 3 over 2 divided by 1/2. Again, the denominators will cancel out, and we are left with radical 3 divided by 1, which is simply radical 3. In precalculus and calculus, we use radians instead of degrees. But just for one moment, I need you to make this connection. 45 degrees is what we will now call pi over 4. Pi over 6 is what we used to call 30 degrees. And 60 degrees is the same as pi over 3 radians. So we are going to only use radians in this class, but sometimes it helps to make the connection with the old school geometry degrees. Please pause the screen and make sure you have memorized the 9 values on this chart, or at least memorize these 3 blue values for sure, and understand how you can get the other 6 values from the blue values. In this space right here, we have the first quadrant of the unit circle. So the radius is 1. And we need to fill in the coordinate of each of these points. And we need to fill in the slope of the terminal side of angle theta. And we need to record the degrees and the radians. So let's start with this angle right here at the very top. This is the angle that we used to call 90 degrees. We will not be saying that anymore. Instead of 90 degrees, we will now say that this is pi over 2 radians. The coordinates of this point are the old school x and y values of a point on the xy plane. This point is on the y-axis, so the x value is 0. And because the radius is 1, the y value is up 1, so the y value is 1. The slope is, well, this is a vertical line. And a vertical line has a slope that is undefined. In general, the slope is the same as the tangent, which is y over x. It's the slope, it is the tangent. If we try to apply this formula, y over x, that would give us 1 over 0. You can't divide by 0, that's why this is undefined. So we just did the value that's on the positive y-axis. Now let's do the value that is on the positive x-axis. This is 0 degrees because we are starting from here and rotating counterclockwise. So on the positive x-axis, it is right at the start. So this is 0 degrees. It is also 0 radians. What are the coordinates of this point? This is old school x and y value. This is 1 unit to the right because the radius is 1. So the x value is 1. This point is on the x-axis. It is not up or down. So the y value is 0. The slope is 0. You can either get that because this is a horizontal line, and we know that all horizontal lines have a slope of 0. Or you can do the formula y over x, same as tangent. Y over x would be 0 divided by 1, which is 0. Let's do the angle right down the middle. This is the angle that we used to call 45 degrees. In radians, this is pi over 4. Memorize that 45 degrees is pi over 4. Remember that on the unit circle, cosine theta is the x value and sine theta is the y value. In other words, any point that you see is going to be written in the form cosine theta, comma, sine theta, if you are on the unit circle. So the coordinates of this point will be cosine pi over 4, comma, sine pi over 4. But that's where the chart comes in. Cosine of pi over 4 is radical 2 over 2. Or you could put 1 over radical 2. So the x-coordinate is radical 2 over 2. The sine of pi over 4 is also radical 2 over 2. So just write that again. The slope of the terminal side is the tangent. And the tangent of pi over 4 is 1. So the slope of pi over 4 is 1. Now let's do the smallest special angle. The smallest special angle is pi over 6. And this is what we used to call 30 degrees. So 30 degrees, pi over 6 radians. The coordinates, as always, well, on the unit circle, are cosine theta, comma, sine theta. So we need the cosine of pi over 6, comma, the sine of pi over 6. Back to the chart. The cosine of pi over 6 is radical 3 over 2. So that is the x-coordinate of pi over 6, radical 3 over 2. The sine of pi over 6 is 1/2. So that's the y-coordinate, 1/2. The slope is the tangent of pi over 6, which is radical 3 over 3. Finally, let's do the angle that is the biggest of these three. The biggest of these three angles is pi over 3. This is the angle that we used to call 60 degrees back in geometry class. So 60 degrees, pi over 3 radians. Because this is the unit circle, the x value will be the cosine of pi over 3. So let's look at the chart. The cosine of pi over 3 is 1/2. The y value will be the sine of pi over 3. The sine of pi over 3 is radical 3 over 2. Radical 3 over 2. And finally, the slope of the terminal side is the tangent. So the tangent of pi over 3 is radical 3. So that is the slope. You can see how useful this chart is. That's why I need you to be able to recreate this chart on a piece of scratch paper. On your next test or quiz, ask your teacher for a piece of scratch paper and quickly write this down, or write it in the margin. For the next several problems, we are going to stick to the unit circle, but we are going to evaluate sine, cosine, and tangent at angles that are beyond the first quadrant. But let's start with evaluating sine, cosine, and tangent at the angle theta equals pi. I want you to memorize that pi is right here. Pi is a semicircle. It's what we used to call 180 degrees. When the terminal side lands right on the x or y axis, I want you to use old school coordinates in order to find the values of sine, cosine, and tangent. So this point is left 1 because this is the unit circle, radius of 1. So the point is 1 to the left, so the x-coordinate is -1. And it is on the x-axis, so the y value is 0. These are the coordinates. On the unit circle, the sine is the y value. So sine of pi is 0. Cosine is the x value. So the cosine of pi is -1. Tangent is y divided by x. 0 divided by -1 is 0. The angle between the terminal ray and the closest part of the x-axis is called the reference angle. We can tell at a glance that the reference angle is pi over 6, because 5 pi over 6 is a multiple of pi over 6. In order to evaluate the sine of 5 pi over 6, first ask yourself, what is the sine of pi over 6? Looking back at the chart, the sine of pi over 6 is 1/2. That means the sine of 5 pi over 6 will also be 1/2, except it might be positive or it might be negative. Just remember that the sine value on the unit circle is the y value. So look at the quadrant that we landed in. Are y values positive or negative in this quadrant? Well, in this quadrant we are above the x-axis where y values are positive. So the sine will be positive 1/2. To evaluate the cosine of 5 pi over 6, first ask yourself, what is the cosine of pi over 6? Let's see. The cosine of pi over 6 is radical 3 over 2. That means the cosine of 5 pi over 6 will also involve radical 3 over 2, only it might be negative. Cosine is the x value on the unit circle. In quadrant 2, where we have landed, the x values are negative. We are to the left of the y-axis. Therefore, the cosine in this quadrant is negative. So the answer is negative radical 3 over 2. To evaluate the tangent of 5 pi over 6, begin with the tangent of pi over 6. The tangent of pi over 6 is radical 3 over 3, or 1 over radical 3. So write that down, radical 3 over 3. It's just that the tangent of 5 pi over 6 might be negative. Just remember that tangent theta is the slope of the terminal side. So this segment has a negative slope. See how it's going downhill? That means that tangent will be negative radical 3 over 3. By the way, if you just want a quick pattern to memorize, tangent will be positive in the first quadrant. All three trig functions are positive in the first quadrant. But the pattern for tangent goes like this: positive in these two quadrants and negative in these two quadrants. Sort of the diagonals are the same. That makes sense with the slope because in these two quadrants, the terminal side of the angle will have a positive slope. See how it's rising from left to right. Whereas in these two quadrants, the slope of the terminal side will be negative. See how the line is falling from left to right in these two quadrants. For the next problem, theta is 4 pi over 3. What quadrant is this in? Remember, pi can be thought of as 3 pi over 3. Therefore, 4 pi over 3 will be one multiple past this. So 4 pi over 3 will be right here in the third quadrant. What is the reference angle? Well, 4 pi over 3 is a multiple of pi over 3. So pi over 3 is the reference angle. If I want to evaluate the sine of 4 pi over 3, I begin with the sine of pi over 3. The sine of pi over 3 is radical 3 over 2. So the sine of 4 pi over 3 will also be radical 3 over 2, but it might be negative radical 3 over 2. The sine of an angle is just the y value on the unit circle. In this quadrant, will the y value be positive or negative? Y values are negative in the third quadrant because we are below the x-axis. So the sine of 4 pi over 3 will be negative radical 3 over 2. If I want to evaluate the cosine of 4 pi over 3, I begin with the cosine of pi over 3. Hopefully you guys will memorize this quickly so I don't have to keep scrolling back and forth. The cosine of pi over 3 is 1/2. That means the cosine of 4 pi over 3 will also involve a 1/2, but it might be negative. On the unit circle, cosine is the x value. In quadrant 3, x values are negative because we are to the left of the y-axis. So the cosine of 4 pi over 3 is negative 1/2. To evaluate the tangent of 4 pi over 3, I begin with the tangent of pi over 3. The tangent of pi over 3 is radical 3. Therefore, the tangent of 4 pi over 3 will also involve radical 3. It might be negative. In the third quadrant, tangent is positive because tangent is the slope, and the slope of this segment is positive. So the tangent of 4 pi over 3 is positive radical 3. For this problem, theta is equal to 3 pi over 4. Let's start by asking ourselves what quadrant this is in. The denominator is a 4, so let's think of pi as 4 pi over 4. 3 pi over 4 will be one multiple before 4 pi over 4. So 3 pi over 4 will be right here in the second quadrant. What is the reference angle? Well, 3 pi over 4 is a multiple of pi over 4. So the reference angle is pi over 4. To evaluate the sine of 3 pi over 4, we begin by evaluating the sine of pi over 4. The sine of pi over 4 is radical 2 over 2, or 1 over radical 2. So the sine of 3 pi over 4 will involve radical 2 over 2, but it might be negative. On the unit circle, sine is the y value. In the second quadrant, y values are positive because we are above the x-axis. So the sine of theta will be positive radical 2 over 2. To evaluate the cosine of 3 pi over 4, we begin with the cosine of pi over 4. The cosine of pi over 4 is also radical 2 over 2. So the cosine of 3 pi over 4 will involve radical 2 over 2, but it might be negative. Cosine is the x value on the unit circle. X values are negative in the second quadrant because we are to the left of the y-axis. So the cosine of 3 pi over 4 is negative radical 2 over 2. Tangent of 3 pi over 4 begins with the tangent of pi over 4. And the tangent of pi over 4 is 1. So the tangent of 3 pi over 4 will also involve a 1, only it might be negative. Tangent is the slope of the terminal ray. The slope of this segment is negative. It's falling from left to right. So the tangent of 3 pi over 4 is negative 1. Last problem. Theta is 11 pi over 6. In what quadrant is 11 pi over 6? We can think of pi as 6 pi over 6. And you know what? We can think of 2 pi, which is over here, as double that, 12 pi over 6. Therefore, 11 pi over 6 will be one multiple before 12 pi over 6. So 11 pi over 6 is going to fall right here in the fourth quadrant. What is the reference angle? I bet you guessed it. The reference angle is pi over 6 because 11 pi over 6 is just a multiple of pi over 6. To evaluate the sine of 11 pi over 6, begin with the sine of pi over 6. the sine of pi over 6 is 1/2. Therefore, the sine of 11 pi over 6 will also involve a 1/2, only it might be negative. On the unit circle, the sine is the y value. Y values will be negative in the fourth quadrant because we are below the x-axis. So the sine of 11 pi over 6 is negative 1/2. To evaluate the cosine of 11 pi over 6, we begin with the cosine of pi over 6. The cosine of pi over 6 is radical 3 over 2. That means the cosine of 11 pi over 6 will involve radical 3 over 2, only it might be negative. On the unit circle, cosine is the x value. And x values are positive in the fourth quadrant because we are to the right of the y-axis. So the cosine of 11 pi over 6 will be positive radical 3 over 2. Finally, to evaluate the tangent of 11 pi over 6, we begin with the tangent of pi over 6. The tangent of pi over 6 is radical 3 over 3, or 1 over radical 3. Therefore, the tangent of 11 pi over 6 will also be radical 3 over 3. Oh, except for it might be negative. Tangent is the slope of the terminal side of the angle. In this quadrant, the terminal side is negative. See how it goes downhill from left to right? Therefore, the tangent of 11 pi over 6 will be negative radical 3 over 3. Or you can just memorize that tangent is positive in these two quadrants and negative in these two quadrants. So, in the fourth quadrant, tangent is negative, so you put a negative. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.